got 239 volts. And then I read my amps. Now you got to get the amps on the common so you don't interfere with the run. I'll set this right here. So the common on the compressor is the black one. So we got 8.5. Common on the fan motor. Should be able to see that. Okay. Common on the fan motor is 0.9. Okay, first I zero out the wet bulb because we got the dual probes here, and there's nothing to zero. It's factory calibrated. The calibration values are actually in the probes, and I just want to confirm that it's working good. So you can see the reading wet bulb right about the same, 62 degrees. And then next I'll start taking some readings. Okay, next I'm going to measure airflow. I got my anemometer. I type in the area of the opening. I always like to measure it on the actual returns rather than in the duct, because there's no turbulence here, and the air is very laminar right by the opening, and get a good reading. So I just take the area, I divide it, convert it into square feet, and this actually enters it in. Let me do that. I do volume, area 2.09, enter, and then I'm going to do an average reading. I'll take several readings. Put the camera here so you can see. So we're going to go 2, 3, 4. So we got 1135 CFM. The average of 4 readings. We can look at our dew point over here. Actually, wet bulb. Wet bulb is what you use to convert in the BTU or BTUs per pound. So I'll write that down. Also, I'll get the dry bulb. Now I'm getting the discharge right on the top of the fan, right there. There's a heater coil, so I'm getting it in between, but it's on the supply side of the fan. And then for the return, it's just room temperature, because these units just have a panel which goes over the return. That's why I put the static pressure at 0 on the return side. Now this will read dry bulb, relative humidity, which you don't need, wet bulb, dew point, and it will calculate BTU per pound, but I will go ahead and I use the chart, which I'll show you on the email. So the chart seems to be a little bit different from the calculation that they're doing in here, and but the chart's accurate, and to 2 decimal places on their BTU reading. So it's a pretty cool tool. I still let it read for about 10 minutes to, especially on the humidity, to equalize. But it seems to be really accurate. Now I get the static pressure, and you read about 0.17. These units don't make much static pressure, and they're all pretty much the same. So 0.17 just right off the top of the unit. And then to get the blower amps, I just grab it from the breaker, and I get the 4.5 amps and the volts. Now this unit I just serviced, it had a freon leak up on the condenser coil, and so I put in a factory charge plus ½ pound for the line, and then you can see right there, so our evaporator's flooded right up to the very top row, and that's with the factory charge. And so these units, they work really good when it's most of the coil is being used for cooling. I pulled that washable filter. They are a little bit restrictive. You see the static pressure went up 0.24. So they can get substantially more air using a regular pleated filter, but I think it's fine because they're still got pretty good airflow with it, and they save some money when they're washing it. But most of the people use pleated air filters out here, just don't have such a drop. I wanted to show filling out the form here, and I made a spreadsheet which basically does all the calculations. I just have to enter in the values that are in green: airflow, wet bulb, what's the size of the unit, and then all the current and measurements, and then basically it calculates all the rest and does it accurately. And I'm basing the enthalpy, I'm doing the enthalpy calculation directly from the wet bulb, right here, and I'm doing that from basically this chart. This is the only chart I could find on the internet, and notice it's in tenths of a degree. We got wet bulb temperature and then tenths, and you basically just cross on the chart. It doesn't match the field piece exactly. They're a few percent different. I was going to call field piece about that, and but this does match the psychrometric chart just for ground, atmospheric pressure, and so I'm assuming this chart is good because everybody seems to reference it on the internet. So basically on the spreadsheet I entered in that entire chart, and which is on the left, and then I'm just using a formula which is like value lookup, and then I'll look up what the value is. Yeah, actually what I do is it's a linear. If you actually look at the internet chart, these are a linear interpolation between each wet bulb degree reading. So this is a non-linear on degrees, and then they're doing a linear in between each degree, and it ended up matching. The internet chart ends up matching my spreadsheet exactly, and here's the linear amount on each change, and you can see it on the curve here, the slope, so it's not a linear curve, and but it's doing linear pieces on each degree, and that saved me the trouble of having to enter in every single value on the chart, and then the person that created that chart, and that's how they did that. But it's accurate enough, probably 1/10%. And so anyway, whatever you put in, it instantly updates on the spreadsheet. And I also run this on my tablet too. So like if I change, 54, notice my 93%, immediately changes to 105 just by a 1 degree difference. And on that, and then in the field, it's nice to have it running on a tablet here, and so I have the same spreadsheet on the tablet, and then I can tell real quick at a glance, what's my capacity going to come in at, what's my EER, which I added that in, and I'm not doing a power factor correction. And so it makes it real fast in the field. You can fill out the chart much quicker using the spreadsheet. You fill out the form, and it's going to be much more accurate too, without any arithmetic mistakes. So I took another video of most of the maintenances that I do are at these condos, and they go really fast because they're all exactly identical. And the ductwork is all consistent, everything's, basically cookie cutter, type stuff. And, but let me know what you think of the video, and also if there's any, rooms for improvement. And I think I'm getting a pretty accurate job done, on capacity. And then that other trick that I do of actually measuring where the flood is on the evaporator, that's actually extremely accurate for getting the last few percent, out of the system. And you can even see the superheat, on expansion valves, which usually you can't adjust anyway. And but actually, I like the flow raters better, out there on those units, because you can get a precise, flood level, like precise superheat on the evaporator coils. And also any questions, let me know, and you can reach me anytime. Thanks for watching.